All right, the first topic of discussion is simple interest. We're going to use this to develop what is used for paying interest in real life, but we need to start with simple interest to give you the ideas. So let's start off with, if you deposit money into a savings account, you may expect to get paid interest. Interest is a fee that borrowers pay for the money. So let me put this down. So interest is a fee paid by the borrower. So when you deposit money into a savings account, you're technically giving the bank a loan, and they're going to do with your money what they want. In return for that, they pay you for the right to have it. So anyways, when you put money into a savings account, the bank will pay you interest. Of course, the interest that they pay you is very low, but they do pay you interest for the money that you put into a savings account. We're going to start with something called simple interest. Now, I should preface this with saying that there is no institution currently in existence that actually uses simple interest, but we're going to use simple interest to develop the more complicated interest that we'll talk about in the next video. So simple interest pays money on only the deposited amount. So money, I should say that's really interest. They're going to pay interest on whatever you have deposited and only on what you've deposited. Let me do an example to illustrate that. The numbers I'm going to be using are made up completely just to illustrate points. They do not indicate that these are the kinds of things that are used nowadays as far as borrowing is concerned. So let's talk about John. John deposits $1,000 into a savings account that pays interest at 5% APR. How much will the account be worth after 1 year? So he puts in $1,000, and we got to figure out how much interest he's going to get for that year. So the interest looks like this. That's going to equal 5% of $1,000. I'm going to drop the symbols right now, and I'll just put the numbers. So that's 0.05 times 1,000. and that equals 50. So he earns $50 in interest. So the account value let's call it A, will equal the amount that he put in. So he's got his $1,000 that he deposited, but then he also gets $50 for interest. So at the end of that year, the total account value is $1,050. Some of the terms that I've used in this example I'll explain. One of them is the term APR. That stands for annual percentage rate. The initial deposit is called the principal. In the last example, we had the total amount was the initial deposit, which was $1,000, plus the interest. So I'm going to call this by the letter P for principal, and then I guess I can call this by the letter I for interest. So at the end of the year, we've got our initial amount that we deposited, plus we've got some extra money. Now, let's take a look at how we got that 50. Well, let's take a look first of all at the I. That was equal to the $50, but what I did is I did 5% of $1,000. Okay, and I changed it to 0.05 times 1,000. Notice what these things are here. This little thing, this 0.05, is the interest rate. I'll call it by a lowercase r. And once again, there is the principal. So the interest, the formula for the interest looks like this. It's the principal, and then you have r. But one thing I didn't put on this is this letter, T. The reason why is because we just did it for 1 year. So technically speaking, we did the following computation in our example. We did PRT, that was equal to the 1,000, and then I had the R. But the T, the reason why I didn't talk about it in that example, because the T was 1 year. So technically speaking, it's PRT. So our formula then for the total amount of the account value looks like this. It looks like the original principal plus the interest, like I said. So that's P plus PRT. Now I'm going to use a small bit of algebra to factor out the P's. And there I have it. This is the formula that I want. So let's call this the simple interest formula. And it looks like the following. A equals P times 1 plus RT. And let me write down what these things are called and what you need to know. So A is the account value, or let's just call it amount. I should probably call it the total amount because it includes interest. P is our principal. R is the interest rate, or the APR. That's an annual percentage. T equals the time in years. so that it matches up with our annual percentage rate. Let's redo the last example using this formula. So for that, we have our A equals P times 1 plus RT. So what I recommend is writing down the formula, and then let's put down all the letters that we know, whose value we know. So for example, we were asked to figure out how much the account value was at the end of a year. So that thing I don't know. But let's see what I do know. P, I knew the principal was $1,000. R was 0.05. Make sure you put it as a decimal or your answers are going to be wrong. And then T was equal to 1 year. So our A is 1,000 times 1 plus 0.05 times 1. That is 1,000 times 1.05, which equals 1,050. And so we know that our final answer is 1,050. Suppose we leave deposit in the bank. How much will the account be worth after A, 5 years, B, 10 years? So it's just a matter of using the formula. Once again, we don't know the amount. The principal I do know to be 1,000. The rate is 0.05. And then the T will vary depending on the question. So part A, we're told the T is equal to 5. Now let me go ahead and find the account value. So I've got P times 1 plus RT. That will equal 1,000 times 1 plus 0.05 times 5. That equals 1,000 times 1.25, which equals 1250. So the account value after 5 years is $1,250. After 10 years, here I'm going to change T to 10, and the formula, once again, if you write down the formula every single time that you do the problems, before you know it, you'll have it memorized without thinking twice about it. Let me put in my numbers. 1 plus 0.05. This time is 10 years. And so this is 1,000 times 1.5. which is 1,500. So the answer to part B is $1,500. Next, let's take a look at a more realistic annual percentage rate. Suppose you deposit $1 million at an APR of 0.1%. How much will the account be worth after 100 years? So let's take a look at the letters that we all have. The principal is 1 million. Of course, the amount, I don't know that. The rate is 0.001. Be careful with your decimals. T equals 100. So let's go ahead and see what we have. A equals P times 1 plus RT. That is 1 million times 1 plus 0.001 times 100. Of course, when you multiply by 100, you simply move the decimal over 2 places. So I'll have 1 million times 1 point. If I move the decimal to the right 2 places, I'll have 1.1. And so that will equal 1,100,000. So total amount, 1,100,000. Next, suppose you deposit $1 into an account that pays 50% APR. How much will the account be worth after 100 years? So let's see what we have. The principal is $1. The account value is the thing we're trying to figure out. The rate is 0.50. Time is, once again, 100. So our amount is P times 1 plus RT, which is 1 times 1 plus 0.5 times 100. That equals 1 times 51, which equals 51. So we'll have a total of $51 after 100 years. Now a couple of other types of questions. How long will it take a savings of $100 to grow to $100,000 at an APR of 2.1%. So this time, let's see what we have. The total amount that we want to achieve is $100,000. I should probably take out the dollar sign because I'm just dealing with the numbers here as I do the problem itself. The principal was 100. The rate is 0.021. Time, that's the thing we're trying to figure out. So let me go ahead and put in my formula and then my numbers. So I have A equals P times 1 plus RT. My A is 100,000. The P is 100. 1 plus R is 0.021 times t. When you're solving problems like this, you probably remember that you want to do something called the distributive property and multiply the 100 through. So I'll have 100 plus. Now, when I multiply the 100 times the 0.021, that decimal place moves to the right 2 places, so that will give me 2.1 t. Now, do your usual bit of algebra. I'll subtract 100 from both sides of this equation, and I'll get 99,900 will equal 2.1 t. If I want to figure out what t is, then I'll divide both sides by 2.1. I'm going to round my answer to 3 decimal places. What I get then is 47,571.429. So how long is it going to take? 47,571.429 years. How long will it take for a savings of $100 to grow to $100,000 if the APR is 15%? So once again, I'm trying to find time. The amount I know to be 100,000. Principal I know to be 100. The rate is 0.15. And then time, that's what I'm trying to figure out. So I put my formula in again. 100,000 equals 100 times 1 plus 0.15 t. I'll do the same thing I did last time. I'm going to distribute the 100 through to get 100 plus 15t, and that's equal to 100,000. Subtract 100 as before. We'll get 99,900 equals 15t, and as before, I will divide by 15. Here I get 6660 equals t, so we'll have 6,660 years is how long it would take. Notice it's substantially less than the previous problem, although it's not short by any stretch of the imagination. Because the interest rate was higher, we have to wait less time to achieve the same goal. What APR would you need for a deposit of $100 to grow to $1 million after 50 years? So here we have our amount, which is 1 million. Our principal is 100. Our rate, I don't know that. Our time, though, I know to be 50. So let's put these all in. I have A equals P times 1 plus RT. That is 100 times 1 plus R times 50. A was what, 1 million? All right, let me distribute as I have all the other problems. Now I can take the 100 and multiply it to the 50. So I add 2 zeros to the 50 and I'll get 5,000 R. That'll equal 1 million. Subtract my 100 as usual. So I'll get 999,900. And that's going to equal 5,000 R. So I'll divide by 5,000. I get R equals 199.98. Remember, this is a decimal. We need to turn it into a percentage. The way you change it to a percentage is you move the decimal to the right 2 places. So R actually equals 19998%. Moving on. What APR would you need for a deposit of $1,000 to grow to $1 million after 500 years? So let's see what information we have. The amount we want it to grow to 1 million. Here the principal is 1,000. The rate is what we're trying to figure out, and the time equals 500. So my A equals P times 1 plus RT. The P is equal to 1,000. R don't know, times 500. And the A was 1 million. All right, I'll distribute as usual. 1,000 plus 1,000 times 500 is 500,000. And then there's the R. Subtract the 1,000. So I'll have 999,000 equals 500,000 R. So I'll go ahead and divide by 500,000. I get R equals 1.998. And once again, we want to turn that into a percentage. So our APR then is 199.8%.